All right, welcome to this video on learning how to find a local maximum or minimum in your Texas Instruments graphing calculator. We're going to run through some examples here. The first thing that we want to find a maximum of is the function 7x minus x cubed. So I'm going to type this in by hitting the y equals key. And then in y1, I'll type in the function 7x, notice where the x button is, minus x cubed, which would be x raised to the power of 3. And now I have that function. The first thing I want to do when I'm looking for a maximum or minimum is I want to look at the function in what's called the standard viewing window. So what I'll do is I'll go to the zoom key and I'll choose option 6, which is the standard zoom window. And what that does, you'll notice on the graph itself, is that gives you the x and y axis, each going from -10 to +10. That's considered our just normal, regular, everyday viewing window or standard window. Now, in order to find the maximum, what you'll notice is above here, above the trace key, there's a calc, and we want to access that calculate feature. So we'll hit second and then calculate. And in there, we'll see that option 4 is maximum. So choose option 4. And now I'm primed to find the maximum of this function. So the first thing that you'll notice is that I'm being asked a series of questions. They're asking me for a left bound. What you want to do at this point is go slightly to the left of where your maximum is. You'll notice if you look at the graph here that our maximum is right. The maximum we're looking for would be right up here. And so to find that, you want to go slightly to the left of that maximum. So what I'm going to do is I'm going to hit the right arrow key enough times until I am just slightly to the left of the maximum that I'm looking for. Once you're there, you want to hit enter to mark that leftmost point or that left bound. You'll notice on the screen, it's now asking you for a right bound. That means we should go slightly to the right of the maximum we're looking for. I'm going to hit the right arrow several times until my cursor is just a little bit to the right of the maximum I'm looking for, and I'll hit enter to mark that rightmost point. The last question being asked of me is the guess. When I'm prompted for guess, I want to put the cursor approximately where the maximum is. It's not going to be there exactly, but that's close enough. And once I get there, I hit enter a third time. And this will calculate the maximum point for me. If you look at the bottom of the screen, you'll notice that this local maximum is at about 1.53, 7.13. And that's how you find the coordinates of a local maximum of a function. But not all functions turn out to be this easy in the sense that you can't always expect for the maximum to just show up in the screen just by you typing in the function. This example that we're going to look at next will illustrate how it's not always quite that simple. So on the next problem, so what I want to do now is go back to the y equals screen and clear out my old function. So since the cursor is on y1, I'll hit clear. And now I'm ready to type in the next example. So for the next example, we're going to look at y equals 100x times the square root of 18 minus x squared. And now that I've typed in this function, I can go to a standard window by hitting zoom and choosing option 6. And what you'll notice here is that you can't see the graph at all. Now that doesn't mean there's no graph. It just means that it's not in the window between -10 and +10 on the x and y axis. We may have to expand out and look further. Now, one option that you can try, and it's not guaranteed to work, but there's an option called zoom fit, where you click the zoom key and you can't see it on the screen, but option 10 would be zoom fit. I'll show you by scrolling down, by hitting the down arrow repeatedly. Option 0 or 10 is zoom fit, and I can then hit the 0 key. And what the calculator has done now is it's changed the viewing window so that we can see what it considers to be the prominent features of the graph. And maybe now we can use it to find the local maximum. But it's worth noting, if you look at the tick marks, say on the x-axis, for example, it seems as though we may have a change in our viewing window. So when you go to your window, which is right here at the top, you'll see that for the x coordinates, we're still looking between -10 and 10. But for the y coordinates, the computer has automatically adjusted our y-axis to go from -900 to +900 approximately, as a means of fitting what it considers to be the important points on this graph. So we kind of lucked out. I'm going to go back to the graph here by hitting graph. We kind of lucked out and found the local maximum by just choosing zoom fit or zoom 0, which is the keystroke you have to hit. And now I can find the maximum like I did before. So I'll go to second, calc, choose option 4 for maximum, and I'll go through the 3 questions again of my left bound, right bound, and guess. Since it's asking me for a left bound, I want to move the cursor so that it's slightly to the left of the maximum I'm looking for. That'll do right there. Hit enter to mark that point. Now it's asking me for a right bound, so I'll go past the maximum that I'm looking for, say here, and I'll click enter to mark the rightmost point. Now it's asking me for a guess, so I'll scroll back and put the cursor approximately where the local maximum is, hit enter again to make that my guess, and what the calculator has done now is found the local maximum for me. You'll see that it's 2.99999 something, comma 900. That's a calculator's way of suggesting that the maximum is probably at the point 3, comma 900. Either way, it's close enough for our purposes. So in this problem, you'll recall what happened is when we first graphed it in the standard viewing window, or zoom 6, we didn't see anything. But then when we chose zoom 0, which is the zoom fit option, the window adjusted so we were looking way farther up and down the y-axis and able to see the prominent features of the graph. We're going to look at one more example here where even zoom fit doesn't come to the rescue. So let me go back to my y equals screen. You see that the cursor is in y1. I'll clear out the old function, and I'll now type in our third example. Suppose we were trying to find the local minimum in quadrant 1 of the function y equals 300 over x plus x, oops, I hit something wrong there, plus x over 50. So I'm going to start in a standard viewing window by hitting zoom 6. And again, what happened is what I predicted would happen, which is that there's no particular graph visible here. So that means the graph is somewhere outside of the standard -10 to 10 viewing window. The first thing I usually try when I can't see my graph is zoom fit or zoom option 0. And you do get some sense of the graph here. But you really, especially with the over-pixelization of everything, you really can't see that there's a local minimum in quadrant 1. But suppose you were told, or we knew that somewhere in quadrant 1, there is a local minimum. If zoom fit doesn't find it for you, the only real option that you have left is to go to your window key and manually adjust the window settings. Notice when we hit zoom fit, this calculator changed our y range from negative 1400 to positive 1400. But that didn't seem to really do it for us. And so one thing that I like to try if I'm looking for a maximum or minimum is looking at much smaller y values and maybe larger x values. I would like to say that there was some formula that I could tell you that would let you know how to choose your viewing window. But honestly, it's in this particular case, it's quite a bit of guess and check. So what I'm going to do is I'm going to first remember that this question asked me only to find the local minimum in quadrant 1. So I really don't need to look at negative numbers at all. I'll put 0 for my x minimum, and I'll also go down to my y minimum and put 0 for that as well. And I just want to show you what that looks like here. It shows us the graph, but only the quadrant 1 portion of the graph, because remember in this question, that's all we were really interested in. Okay, but it still doesn't appear like I have a local minimum. In fact, it would appear as though this graph is just approaching the x-axis as we go further and further towards the right. But one way that you can find a local minimum is to look further out to the right. At this moment, you'll notice, if we go back to our window, that the x value is only going up to 10. What if we tried looking out, say, to 100 and see what would happen there? All right, well, let's graph the thing then by hitting graph. And it looks like we're looking way further out now. And you can find yourself quite often just essentially readjusting your window over and over and not really knowing what it is exactly that you're seeing. Well, one thing that can distort a window is really large numbers. So you see the number 1400, that was placed there when we hit zoom 0 or zoom fit. Let's go back to that and put in a more reasonable size number like 10. And I'm going to hit graph again this time. And now we're looking at a much different window, and it looks like this graph may hit a minimum far off to the right, but we can't really see it yet. So my next best guess, and you'll notice all I'm doing here is arbitrary guess and check. There's no real strategy here. Is I'm going to hit the window key and look farther out than 100. So I'm going to change that 100 into 200, or I could change it to 300. And I'm going to hit graph again and see if I see a minimum now. And it does appear that there is a minimum in this graph. Now it's extremely pixelated, and let me draw something here with my cursor. But my guess is that somewhere in this bottom, what appears to be a linear part of the function, but probably isn't, and that's just a computer flaw essentially, in the fact that there's so few pixels on the Texas Instruments calculator. So my guess is that somewhere in there, there's a minimum. So in order to find it, here we go. I'm going to go to second calc. This time, instead of option 4 for maximum, I'm going to choose option 3 for minimum. And I'm going to answer my 3 questions again. The left bound means to go slightly to the left of where I expect the minimum to be. I'll go right here. Good enough. Doesn't have to be perfect. And I'll hit enter to mark the left bound. Now it's asking me for a right bound, so I will go past where I think the minimum is. I'm guessing the minimum is here. And you can see the y values as I scroll across, and you can see that they do appear to be getting large, a little bit larger now. So I'll use this as my right bound because it's to the right of the minimum I'm looking for. I'll hit enter to mark that. And thirdly, it's asking me for a guess, which means to go back to where I think the minimum might be. I really don't know, so I'll just pick a point in the middle there and hit enter. And once I do, the graphing calculator has found the local minimum for me. And you can see at the bottom of the screen that the local minimum is about 122.5, 4.9 roughly. Thank you for watching this video on finding local maxima and minima, and good luck on your problem.